purpose of this video is to give you some help with your 3.1 to 3.4 review homework. So we're going to go through and work just a few of these problems to give you some help to get you going, so hopefully you can finish the rest on your own. For numbers 1 through 4, I just want to give you one hint about the direction. Notice it says circle the word or words that best complete each statement. So there might be one of these that has more than one right answer. In other words, you'll be circling more than one answer. So just a heads up about that. Let's go down and look at this section, numbers 5 through 9. Want to remind you in the directions about this, that A, you're given that A is parallel to B. So why don't you go ahead on your worksheet and mark line A parallel to line B. And then let's do number 5 together. The directions say state the postulate or theorem that justifies each conclusion. Okay, so if I'm given that line A is parallel to line B, what postulate or theorem could I use to do number 5? In other words, it would guarantee that angle 1 is congruent to angle 8. Okay, well, clearly this is going to have something to do with alternate exterior angles, because those two angles are on alternating sides of the transversal and on the exterior of the two lines, and also it has something to do with parallel lines. But remember, there's an alternate exterior angles theorem and a converse of the alternate exterior angles theorem, so make sure you get the right one. You should be looking for a theorem that assumes you have parallel lines and then concludes that you have alternate exterior angles congruent. So you might want to take a look at your yellow sheet, and that would be the alternate exterior angles theorem, which says if two lines being cut by a transversal are parallel, we may conclude that alternate exterior angles are congruent. Okay, so for the rest of these, if it's one of these, if your reason is going to be one of these angles that has to do with parallel lines cut by a transversal, make sure that you write the shorthand version of the theorem or postulate and not just the name. Okay? All right, then let's take a look at number 10. Kind of the same thing. It says state the postulate or theorem. We're doing number 10 right now. State the postulate or theorem in shorthand that allows you to conclude that J is parallel to K, line J parallel to K. All right? So make sure you look at the portion of your yellow sheet where the postulates and theorems, where the conclusion is that you have parallel lines. So looking at number 10, this is similar to the one we just looked at. We have a transversal that's intersecting two other lines. These 75-degree angles are on alternating sides of the transversal and on the exterior of the two lines. Here's the interior, so the 75-degree angles are on the exterior. So what guarantees that line J is parallel to line K? That would be the converse of the alternate exterior angles theorem. So you would say when alternate exterior, or if alternate exterior angles are congruent, we may conclude that we have parallel lines. So make sure that your conclusion on these is that you have parallel lines. Okay. Then I also wanted to help you with this section. Let's do number 14 together. The directions here say use the figure and the given information to determine which lines, if any, are parallel. So there might be some where you can't conclude any lines are parallel. Just a heads up about that. Justify using a theorem or postulate. Okay, so if we're given that angle 9 is congruent to angle 16, so take a look at the picture over here. Okay, there, I keep picking ones that have the same situation. 9 and 16, notice that we have a transversal here intersecting two other lines. The two angles I marked are on alternating sides of the transversal and again on the exterior of these two lines. So if I'm given that angle 9 is congruent to angle 16, then I can conclude that these two lines, line A and line B, are parallel. So we'd finish here and say A is parallel to B, and then the reason would be when alternate exterior angles are congruent, we may conclude that we have parallel lines. Again, please don't write the name of these postulates and theorems if it has to do with parallel lines in a transversal, make sure you write the shorthand version. All right, the next one I want to help you with is number 21. So let's take a look at that proof. Okay, in this proof, we are given that lines A and B are parallel and lines C and D are parallel. And from that, we're going to prove that the measure of angle 2 plus the measure of angle 11 is 180. Okay, so let's just help a little bit. Let's do something that might help visualize this a little bit. I'm going to mark the angles that are congruent with a color. So I'm going to start with lines A and B, and I'm just going to highlight them in yellow. Okay, so we have the yellow lines parallel to each other, and then I'm going to highlight the other two lines. Oh, how about it with green? Okay. Line C is parallel to line D. All right, so given that, let's prove that the measure of 2 plus the measure of 11 is 180. Okay, so let's take a look at the first step. Our reason is given, so it must be one of these two pieces of information. Well, if we're going to follow step 1 with something about angles 2 and 3, I think we want to be talking about these yellow lines. So let's go ahead and say A is parallel to B. Line A is parallel to line B. The reason is because it's given. We're assuming that that's true. Okay? Now, if I have parallel lines, how can I conclude that 2 and 3 are supplementary? Well, remember the sorry, I'm having a brain cramp. The supplementary angles theorem, which says when parallel lines are cut by a transversal, same side interior angle. Sorry, I could not think of the name of that for some reason. Okay, when parallel lines are cut by a transversal, we may conclude that same side interior angles are supplementary. All right, and if those angles are supplementary, then if you look at your blue sheet and the definition of supplementary angles, we can say that the measure of angle 2 plus the measure of angle 3 add up. Those two measures add up to 180 degrees. Why is that true? Because of the definition of supplementary angles, which says two angles are supplementary if and only if their measures add up to 180. Okay? Now, let's go to the other piece of given information. Okay, that would be the green lines over here. We were also given that C is parallel to D. Okay, line C parallel to line D. Why is that true? Because we assumed it to be true. It was given. Okay, so now, if C and D are parallel, then I want you to take a look at angles 3 and 11. Okay, what would you conclude about angles 3 and 11? Well, if I have parallel lines cut by a transversal, then I can say that angle 3 is congruent to angle 11. And the reason, when parallel lines are cut by a transversal, what kind of a pair of angles are 3 and 11? They are corresponding angles. I can conclude that corresponding angles are congruent. All right, now I think I'm going to leave the rest of this to finish for you, but I'm going to give you a couple of hints. Okay, if angles 3 and 11 are congruent, that means that their measures are equal. That would be your next step, to say that their measures are equal. Then, if the measure of angle 3 is the same as the measure of angle 11, I can take step 3 and rewrite this whole statement, this whole equation, except I'm going to replace the measure of angle 3 with what it's equal to. All right, so that's the hint for number 6 and 7. Okay, the last problem I'm going to help you with is on the last page, if you want to turn to number 26. Okay, the rest of the proofs have some helps for you, so this one I'm going to give you some hints about. Okay, we're to prove this statement. If two lines are cut by a transversal, then we're going to prove that same side exterior angles are supplementary. All right, so I've underlined the hypothesis one time. We use the hypothesis to write our given statement, but we're going to write our given statement in terms of this diagram. Okay, so we have two parallel lines cut by a transversal. Well, the two lines we would be talking about are M and N. So we are going to assume that line M is parallel to line N, and that what we're going to prove is that same side exterior angles are supplementary. Well, what do you think the angles we're going to be referring to? That would be angles 1 and 3. Notice they're on the same side of the transversal and they're on the exterior of the two lines being cut by the transversal. So we're going to prove that angle 1 and angle 3 are supplementary. Okay, so I guess a good place to start is with our given statement. Let's go ahead and state that line M is parallel to N. Since we're assuming that to be true, let's go ahead and mark it on our diagram. And the reason is given. We are assuming that to be true. Okay, now look at your diagram and I want you to look at angles 1 and 2. Okay, what kind of a pair of angles are those? Well, they are corresponding angles, and the corresponding angles postulate says when parallel lines are cut by a transversal, corresponding angles are congruent. So let's go ahead and say angle 1 is congruent to angle 2. Reason, parallel lines cut by a transversal, we may conclude that corresponding angles are congruent. Okay, now if angles 1 and 2 are congruent, then their measures would be equal. The measure of angle 1 is equal to the measure of angle 2. I want you to come up with that reason. It's on your blue sheet. Okay, we just said these angles were congruent. Why can we conclude that their measures are equal? Okay. Now, the next thing I want to do is take a look at angles 2 and 3. Now, what kind of a pair of angles are they? They're adjacent and their non-common sides form a straight line. So angles 2 and 3 form a linear pair of angles. Angle 2 and angle 3 form a linear pair. Oh, sorry about that. Okay, linear pair. Now, again, you're going to come up with that reason. Look at your blue sheet, okay? I'll give you a big hint. 2 and 3 are adjacent, and their non-common sides form a straight line, so they satisfy a definition. There, big hint for you. Okay, now, if they form a linear pair, then remember that linear pair theorem, okay? I'm going to go ahead and write the reason for number 5 for you. Or number 4, I'm sorry. Oh, hold on, measures. I think I might have made a mistake. Measure 1 equals 2. 2 and 3. Oh, I think we're going to have to add a step to this. Okay, 2 and 3 form a linear pair. Again, you're going to find that. Now, I'm going to put the reason for step 5. The reason in step 5 that I'm going to say is the linear pair theorem. So look at your blue sheet, look at that linear pair theorem, and see if you can figure out what statement that I am backing up with the linear pair theorem. It has something to do with angles 2 and 3. Okay? Now, once you figure out what 5 is, I'm going to give you a hint what follows from that. What would follow from that is that the measure of angle 2 plus the measure of angle 3 total 180 degrees. Okay? Again, I want you to find that reason. Okay? And if 2 and 3, okay, if they total 180 degrees, can I make a replacement, rewrite step 6, but instead of saying that the measure of angle 2 plus the measure of angle 3 equals 180 degrees, could I replace this measure of angle 2 with what it is equal to? All right? So if we do that, if we make that replacement, okay, you would go ahead and do that, give a reason, and then we're going to have to add one more step. Okay, and I'm just going to leave it to you to figure out what that last step would be. I think you know that the statement would be that angles 1 and 3 are supplementary, okay, and then I want you to come up with the reason. Okay, if you have any more questions about this 3.1 through 3.4 worksheet, be sure and ask me when you see me in class.